We go again. Welcome to NECO 2026 Physics, Theory and Objective. We are taking the theory first, so stay tuned to the objective. And we are doing the theory in two parts, part 1 and part 2. Part 1, the first 11 questions, and part 2, first 12 to 17 questions. So we are going to solve all of them. Stay tuned so you can have a maximum score tomorrow. Let's go to question 1. So question 1 says, mention two material required for the construction of a DC generator. We know DC generator is made up of a lot of material. So let's go. Number 1A. Materials contain 1. The armature field. Armature field windings. That's one of the materials used to produce a DC. Number 2, we have the commutator. If you know the diagram for DC, you should know all these parts. Number 3, I'm going to list 5. You take any 2. Number 3, we have the brushes. The brushes, they are close to the edges of the DC. Number 4, we have the shaft. Yes, the brushes are connected to the shaft. And number 5, we have the yoke. So you can take any two from this, according to question 1A. Question 1A is compulsory, 1A to 1C. 1B says distinguish between flat plates and focusing collectors. I have two types of collector, flat and focusing. So 1B. So what are flat collectors? Flat plate collectors. Flat plate collectors are best suited. They are best suited for low temperature. They are suited for low temperature. Best suited for low temperature for solar water heating. So this topic falls under solar collector, solar water heating, and swimming pools, and warming swimming pools, So that is what the flat plate collectors does. Why the second, which is the focusing collector? Why the focusing collector? You know, it should be the opposite of the first. Focusing collectors is best suited for high temperatures. High temperature industrial processes such as thermal power plants for electricity. The word thermal means heat. Thermal power plants for electricity. So that's the difference between the flat plates and the focusing collectors. So let's go to 1C. It said a magnification produced by an object lens of a compound microscope is this. So the object magnification, which is my 1C now, my MO, which is the object magnification, is 4. So let's go. So if the magnifying power of the microscope is 20, so my M is simply 20. Going to say calculate the magnification of the eyepiece. So my ME, I just know. We know that M is simply MO times ME. So therefore, my ME will give me M over MO, which is simply 20 divided by 4. The result will give us 5. So 5 is the answer. So if you can answer question 1 correctly the way it is, you obtain your 5 marks. Let's go to question 2. Let's go to question 2. Question 2 says, let me increase it and see clearly. Question 2 says, state 2 physical quantities measured in meter per seconds. Very simple question. So 2A. 2 physical quantities measured in meter per second. One of them is velocity, is measured in meter per second, and the second one is speed. So those are the 2 quantities can be measured in meter per seconds. Then B, distinguish these 2 quantities stated in one above. Very simple. So 2B, velocity, you can differentiate them. Let me make 2 differences. Velocity is defined, you can differentiate them using the definition, is defined as the rate of change of displacement with respect to time. Then y, so let's define speed now. Y speed is the rate of change of distance. The first one is displacement, this one is distance, rate of change of distance with respect to time. So this is one way you can differentiate them. So we're going to take it another way to differentiate it. That's why I'll state it 2. It can be up to 3. Let's take the second one first. There's time. I put this third one. Velocity is a vector quantity. Velocity is a vector quantity. Then y speed is a scalar quantity. So that is the difference between, that's another difference between speed and velocity. Then 3, I can still use their formula to define them. Velocity can be written as, velocity is simply displacement over time. Y speed, let's see what speed can give to us now. Y speed is equals to distance over time. So these are the 3 differences between speed and velocity. So you can write any one of them as the differences. Let's go to question 3. Question 3 says, state the mathematical relationship between period and length of oscillation. So this is question 3, mathematical relationship between period and length of oscillation. We know that period is 2 pi, this is 3a, 2 pi root L over G. So we can say period is proportional to the square root of L. So any of them can be the mathematical relationship between period and length. So let's go to 3b. It said an oscillating simple pendulum has an angular speed of this. Calculate its period. So they give us the angular speed. The angular speed, don't forget, is also called the omega. So with the symbol, this is angular speed, give it to us as 0.5 pi radian per seconds. So we are looking for the speed, the period, I don't know. So we know that omega, which is angular velocity, is 2 pi f. And frequency itself is simply 1 over period. So if I substitute the values, what are we having? We're going to have omega equals to 2 pi over t, which equals to 0.5 pi. That's the value of the omega. So if I make t the Solar formula, what am I having? Our t will give me 2 pi over 0.5 pi. So pi will cancel pi. I'm left with 2 over 0.5. The answer is 4 seconds. That's the answer for the period. Don't forget to subscribe, like, and share this video to friends and others. Let's go to question 4. Let's go to question 4 and see. Question 4 says a body P moving with a velocity of 30 meters per second collide with another body Q of mass 10 kg moving in the opposite direction with a velocity of 15. If both bodies move in the same direction of P after collision at a velocity of 25 meters per second, calculate the mass of P. This question is under the conservation of linear momentum. So let's see that. So let's see what is given to us. The mass of P, that's what we are looking for. Number 4. So mass of P, I don't know. Then initial velocity of P is given to us as 30 meters per second. Then the mass of Q was given to us as 10 kg. Then the initial velocity of Q was given to us as 15 meters per second. So the velocity after collision now, which is V, which is common velocity, is given to us as 25 meters per second. So from conservation of linear momentum, we know that from, you can just state it, from conservation of linear momentum, we know that momentum before this is how you write before collision. You must state the expression which support the law. That causes momentum after collision. So what's momentum? We know that momentum is mass times velocity. So before collision will be mass of P, initial velocity of P. But don't forget, let me draw the diagram for clarity purpose. Let me draw the diagram so that you can see. So P, let's say this mass of P now, which is MP, moving with a velocity of 30 meters per second. Then this is MQ now is 10. It says moving in opposite direction, which is heading this way, with a velocity of 15 meters per second. This is before collision. So after collision, the two bodies move together. This is now MP. This is now 10 kg. Both of them move. It says they move direction of P, which is arrow will be heading this way, with a velocity of 25 meters per second. Okay. So what is now the momentum before collision? Momentum we know is mass times velocity. For the first body, I'm going to have MP times 30. Here will be minus, not plus, because this body is moving in opposite direction. So I'm going to have opposite direction to this body. You can see the arrow, they are in opposite direction. So I'm going to have 10, which is mass times the velocity, is equals to the second body now, which is MP plus 10 times 25, which is after the collision. With bodies stick together and move with the common velocity. So if I simplify what I have, I'm going to have 30 MP minus 150 is equals to, I can put the bracket here, it will give us 25 MP plus 250. So what happens from here, we can simply collect like terms. So if I do that, I'm going to have 30 MP minus 25 MP is equals to 250 plus 150. This will give us 400. Yep, we are where you give us 5 MP is equals to 400. So what is now our MP? Our MP now will be 400 divided by what? 5, which is 80 kilogram. This is not the mass of P. It's simply 80 kilogram. So let's see what question B says. So what types of collision is described in A above? We know we have two types of collision. We have elastic and inelastic. So when the bodies stick together and move with a common velocity, it's an inelastic collision. So for B, collision is inelastic. Although they didn't answer to state why, so you just state the collision is what? Inelastic. So let's go to question 5. Question 5a. It said mention 2 types of machine other than lever. We know we have different types of machine. The lever is always the first one. So let's see. It said we should screw lever. So we have the screw jack. It's a type of machine. Then number 1. Number 2, we have the inclined plane. It's a machine also. Any 2. So I'm writing as much as I can. Number 3, you have the jet. You can take any 2 to jet it. Number 4, we have the wheel and axle. Then number 5, we have the pulley system. Number 6, we have the wedge. All these are types of machine. Okay, maybe there are other types. There could be other types. So you're picking into from here. These are the type of machine that we have. Okay. Then let's go to question 6. No, question 5 is not all. You say differentiate between kinetic and potential and kinetic energies. So question 5b, I mean, PE, which is potential energy, is the energy possessed. Let me state 2 differences. Is the energy possessed by a body by virtue of its position. This is one difference. Why KE is the energy possessed by a body by virtue of its motion. So you can use that definition to differentiate them. Or number 2, I can also use the mathematical formula to differentiate them. I know that PE is simply mgh, while KE is simply half mv squared. So I can also use the mathematical formula to differentiate both of them. So let's look at question 6. Question 6 says state 2 examples of electromagnetic waves with frequency higher than the visible light. Question 6a. If you have not followed us, please do so before we go to just click the subscribe button, like and share. Let's go to question 6a. Now question 6 says mention 2 examples of electromagnetic waves other than the visible light. So we know the example of electromagnetic wave. Let me just state all of them first before we start taking the question. Let me state all of them. We know that electromagnetic waves, I have an acronym ROI, VU, G. All these are examples of the electromagnetic wave. So they are asking about us. This is here is increasing frequency. Okay. Then no, this other side is increasing frequency, while this other side is going this way, increasing wavelength. So let's see. So higher frequency than visible light. So this is the visible light, which is our VA. So who have the higher frequency than the visible light? Number 1, we have the ultraviolet has the higher frequency. Then 2, we have the microwave has the higher frequency. Number 3, we have the X-ray has the higher frequency. And number 4, we have the gamma ray has a higher frequency. So any two can serve. So let's go to number 6b. State one differences between mechanical wave and electromagnetic waves. These are common questions. Let's do that. Question 6b. So mechanical waves, can I use the examples or can I just define them? Mechanical waves are waves that requires a material medium, for their propagation, So why electromagnetic waves are waves that do not require a material medium for their propagation. So this is the difference between mechanical waves and electromagnetic waves. So question 6b has been taken care of, and 6a. So let's go to question 7. Question 7 says, it says a frequency vibrator is used to generate wave in ripple tank. If the speed of the waves in two different regions are this and this, calculate the difference in their wavelength. So you can start to solve it directly, or you can just illustrate with a diagram first. Number 7, if I should drop the wave motion, so let's assume one wave is going this way, then the other is like this. Now you can see we have two different waves, so each of them we have difference. Let me increase this one a little bit. So here and here is the first wavelength, let's call it lambda 1, while here and here is second wavelength, let's call it lambda 2. So you can see both of them will produce different amplitude. Okay, so the velocities is 1 for lambda 1 is 1, for lambda 2 is 0.4. So we know from where that v equals to f lambda. So I'm going to have v1 equals to f lambda 1. Okay, frequency is constant, so my first lambda is now v1 over f, which is 1 divided by 50. The answer will give us 0.02 meters. So for the second wavelength, I'm going to have lambda 2 will be v2 over f. What is my lambda 2? 0.4. v2 is 0.4, frequency is 50. What are we having? 0.008 meter. If I should divide from my end here, this is what I will have. Now, change the lambda now. Change the lambda, which is the difference, is lambda 1 minus what? Lambda 2. What are we having? 0.02 minus 0.008. So if I should subtract from my end here, change in lambda will give us 0.02 minus 0.08. I'm going to have, my calculator, I'm having 0.012 meters. That is the differences in change in wavelengths. So let's go to question 8. Question 8 is, what is meant by the statement, the escape velocity of a satellite from the Earth is this? So let's start by understand what is escape velocity. Is the minimum velocity required by an object to escape or leave the gravitational pull. So how do we relate it to this statement that is 11 kilometer per second? So I'm going to have it as number 8a. Escape velocity means, well, let me put it this way. The statement means that the minimum velocity required by the satellite, which is delivered through a rocket, the minimum velocity required by the satellite to leave or escape the gravitational pull of the Earth, gravitational pull of the Earth is 11 kilometers per second. So you can actually estimate this value by quoting the formula of escape velocity. VE, this formula is square root of 2gr, where g is 10, our r is radius of Earth, which is 6.4 times 10 to the power 6. So if you substitute this value here, we substitute value now into the formula of escape velocity. If you have 2 times 10 times 6.4 times 10 to the power 6, it's going to give you 11 times 10 to the power 3 meter per second. So this is 1000 is a kilometer. So my VE now will give us 11 kilometer per second. So you can actually estimate this value, which is the minimum velocity required for an object to leave or escape the gravitational pull, so referred to as escape velocity. So let's go to question 8b. So take one advantage of acid layer accumulator over Lichtenstein cell. So you've done this under current electricity. It's a topic in SS3. So one advantage of acid lead, which is the H2SO4 and the Lichtenstein cell. So one of them, the acid lead is a secondary cell, while the Lichtenstein is a primary cell. Number 9 now, the acid one, let me state as many differences as I can. Acid lead accumulator is a secondary cell. Why? You must state it this way: why the Lichtenstein cell is a primary cell. This is one difference. Number 2, you can say the acid lead is a secondary cell. That means it's rechargeable. The acid lead accumulator can be recharged. After used. Why the Lichtenstein cell? Why the Lichtenstein? I like that name. Lichtenstein cell is not rechargeable. Okay, or cannot be recharged. That is another difference. Then another difference. Okay, let me make it 3. The acid lead accumulator produces so it can be recharged, and that means it can produce a very high current, because anytime you recharge, the current will be high. A high current, that means it has a low internal resistance, like high current output, and has low internal resistance. So the opposite should be for Lichtenstein. Y, the wet Lincoln shape, right? The wet Lincoln shape cell produces low current, and has high. Okay, that's you can make it 4. Can you use their current to differentiate? They can use the internal resistance and differentiate. So we are just indirectly we are stating for differences here. Has high current, has low current, and high internal resistance. So as much as you can simplify this, because I'm using AND, which is a compact statement. There are 2 things there, so that can make it 4 differences. So let's look at question 9. It says a moving coil galvanometer with an internal resistance of this has a Fourier deflection when a current of 20 milliampere passes through it. Calculate the value of the resistor that will enable it to read 10 ampere at full scale deflection. So let's take the data we have. Question 9. They gave us the resistance galvanometer as 5 ohms. They gave us the current galvanometer, which is my IG, is 20 milliampere. So you must convert it to ampere, which is 20 over 1000. That will give us 0.02 ampere. Okay. While the current we produce, which is my I, is 10 ampere, then the resistance now I do not know. So what is the mathematical relationship for all of them? We have R, which is our resistance, is now IGRG over I minus IG. So I'm having the 0.02 times 5 over 10 minus 0.02. So this is simple as that. So let's see, my arrow now becomes what? If I multiply the up, it gives me 0.10. If I subtract the denominator, I'm going to have 9.98. If I divide what I might have, it gives me 0.010 ohms. Or you can just write it as 0.01, put the symbol of ohms. Any one of them can serve. So this is question number 9. So let's go to question 10. So like I said, follow the channel if you want more exciting videos such as this. Like, subscribe, share with friends, and make sure you follow up with the second part and also the objective. All will be treated in this video, and each of them we will put the link to the previous one. So let's see question number 10. Then the objective will also be there. Very important. Objective will also be there. Very, very important. So make sure you follow through. Question 10 says, draw the unit cell of a body center cubic crystal, also called BCC. Body center cubic crystal is referred to as a BCC. This is under crystals in SS1 topic. So let's draw the structure. We all know how to draw box in our primary school. Let me draw this box this way. There's number 10 now. 10A. Okay, let me draw it this way. So I can join here, 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 and here. So the crystal will be here. The crystal will be here. Okay, the center crystal will be there. So here is a crystal. 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 So you can connect them to the center cubic. Connect the crystals to the center cubic. So this is how to draw a BCC crystal. So this I just have to draw a BCC crystal, simple as such. Okay, so let's see 10B. Let's see 10B. 10B. It says mention two ways of reducing surface tension of water. We know what surface tension is: normal force acting on an imaginary line drawn from the surface of a liquid. So that's why inside want of water, needle float of water. These are some of the examples of the phenomena called surface tension. So let's see 10B. So what can we reduce surface tension? You can use alcohol to do that. Number one, I use alcohol to do so. Number two, you can use grease to do so. Number three, you can use kerosene to do so. And number four, we can use camphor to do so. So you can pick any two from these four. Pick any two from these four and see. Then question 11, it said we should mention two components of a photocell. A photocell is under SS3 topic, if I'm not mistaken, and it's under cathode ray tube. Let's see number 11. A component of a photocell. So I'm going to mention a few. Number one, we have the evacuated glass. Evacuated glass. Two, we have the cathode. And three, we have the anode. Then four, we have the terminals. Okay, we have the terminals. So any of these ones can serve. Then question 11B says the velocity of an electron is given by this, where h, me, and letter a are constant mass, Planck constant mass, and the wavelength of the electron respectively. Express the kinetic energy of the electron in terms of the given parameters. So let's see 11B. They gave us VE, velocity of the electron, as h over me lambda e. And we know that kinetic energy is simply half mv squared. So for electron, it will be E for electron, mass of the electron, velocity of the electron. So if I substitute now the velocity in place of kinetic energy, I'm having 1 over 2 me into h over me lambda e raised to power 2. Okay, I'm substituting velocity now. Let me call equation 1 and equation 2. I'm substituting velocity now from 1 into 2. So if I should simplify what I have, what am I going to have as kinetic energy now? My Ke will be 1 over 2 me times, so I should square, I'm having a square over m square e lambda square e. But this will affect every parameter in the bracket. So one of them can cancel one, so my Ke becomes what? Becomes h square over 2 me lambda square e. So this is the expression. I call it equation 3. Okay, that's the expression for the kinetic energy. So that is the whole of question 1 to 11. That is section A. So I'm going to I want to handle section B now. I'll put the link in section A. I also post the video, so follow up to see the solution to question 12 down to 17. So stay tuned. After which I will also post the objective questions, step-by-step solution for the objective. Make sure you follow, like, and share this video so I can have a successful exams tomorrow.